Hi guys, I want you to consider something. If you know just one point on a line and you also know its slope, will you be able to graph that line and write its equation? And you might remember we did something similar to that in the last section when we knew a point. Specifically, we knew the y-intercept. We also knew the slope. And so starting at the y-intercept, you could use the slope using the rise and the run to find another point. Then you have 2 points and you can draw the line. So yes, with any point, the same trick will work. If you know the slope as well, you can use the rise and the run, make another point, and draw that line. And so you should also be able to write its equation. And in fact, there is a form of the equation called the point-slope form. And section 2.3 deals with that. So that's what we'll look at. Going back, we learned that y equals mx plus b is the slope-intercept form because we can write an equation in that form by just plugging in the slope and y-intercept. Okay, so today we will learn the point-slope form, and here it is. And in this form, what you plug in is the y-coordinate of a particular point on the line, and also the x-coordinate of that same point, and the slope. And you plug in those three numbers, and you have the equation for that line in the point-slope form. I want to point something out to try to get rid of some confusion that often happens, and I remember this confused me when I first learned this. Is this y sub 1 looks kind of like y, and x sub 1 looks kind of like x, but don't confuse those. X and y are the variables in the equation, and they're going to remain there. They're going to be variables. X sub 1 and y sub 1 are not variables. In the point-slope form, they are because we can plug something in, but they're not going to remain variables. We will plug in numbers for those, specific numbers, specifically the coordinates of the point that we have. That's what goes in for the x sub 1 and the y sub 1. And again, we plug in the slope for m, and we have the equation of the line and point slope form. Okay, so if we know the slope and the coordinates of any point on the line, we can plug them in to find the equation of the line, and that's what we'll do in this first example. It says find the equation of a line with slope equals negative 3/4 that passes through the point negative 2, comma 2. So that's our point that's on the line, that's our slope, that should be all we need. We'll plug it in. So here I have the equation again down here. I have the things that we're going to substitute in numbers for in blue. That's y sub 1, m, and x sub 1. And then I wrote it down again below and left gaps for those so that we could plug those in. And we're going to plug in again for y sub 1. It will be this 2, right, because that's the y coordinate of the point. For x sub 1 it will be negative 2. For the slope it will be negative 3/4. So let's do that, and there they are. And then we do go ahead and simplify this by, let's see here, sorry. Taking the negative of negative 2, that's plus 2. So we will go ahead and do that. Minus the negative 2 is plus 2. Okay. So sometimes there's, some minor simplification like that, and then you have the point slope form. Okay. Now the point remains -2, 2, but we just changed the subtracting a negative to a plus. Alright, so next example, we want to convert to slope-intercept form. This is a common type of problem because the point-slope form is extremely convenient to get the equation of a line if you have a point and the slope. You just plug them in. But we may not want to leave it in that form because the slope-intercept form is in some ways it's better and more useful. So once we get the equation in point-slope form, we may change it to slope-intercept form. So let's look at that. The first step is to distribute. Okay, and so we have that here. All we did was go ahead and distribute -3 times x and -3 times -1. So it becomes -3x plus 3. Okay, the next thing we're going to do is go ahead and get y by itself by adding or subtracting. Okay, so we have y plus 4. We want it to just be y on the left. So we subtract 4 from both sides. That's right here. And then we get y equals -3x minus 1. And that's great. That's the slope-intercept form, right? It's y equals something times x. That is the slope times x. And then plus b. So b is -1 here. And we've got it. So note that what we really did was we solved for y. And that puts it in slope-intercept form when you solve for y. Okay, so our next example is graphing. So if we have an equation in point-slope form, what we're going to do is the first thing we're going to do is we're going to get it into slope-intercept form, and then we're used to writing the graph from that, right? That's what we did yesterday. So we'll first get it into slope-intercept form, just like we did this one above. So here's our example. Graph this line. Notice this is in point-slope form because it's y minus something, that's the y sub 1, equals the slope, a number which is the slope, times x minus something, that's the x sub 1. That's point-slope form. Okay, so let's look at the next thing. First step is to distribute. Okay, which this is the same process we just did on the one before. So we take the half times the x, the half times the -6, and we get a half x minus 3. And do you remember the next step? That's to get y by itself, right? And there it is. Get y by itself. And that means adding 2 to both sides. Okay, good old algebra. And we have y by itself on the left, and on the right we have a half x minus 1. And that's in slope-intercept form. We're now going to use that to graph just like we did the other day. So we're going to plot that y-intercept on the y-axis, and then we're going to use the slope to move from that point to the next, and then by using slope equals rise over run, and the slope is 1/2. We pull that out of our slope-intercept form of the equation. The rise over run is 1/2. So the rise is 1, the run is 2. So let's do that. So our point on the y-axis is, the intercept is -1, right? So we go right there to -1, and we put that there. And then we're going to use the slope to move from this point to the next. And the slope is 1/2. So that's the rise over run. So the rise is 1. So we go up 1. I'll draw a little arrow there. Up 1. And the run is 2. So we go over 2. Okay, up 1/2. And then that gives us our next point. Okay? And then we connect those to make the line. And that's it. We have graphed that line. Okay, so I'm just checking the notes to make sure that's all I needed to include. I think it is. So we'll do some more examples of these, of course, in the homework. Hopefully that's enough to get you started. So see you later.